Hello folks, and welcome. In this short Rust video, I'll be showing you some iterator adapters to make handling ownership a bit easier. In this example, we have a slice of bytes, and we're trying to take the first 4 elements and collect them into a vec of bytes. As you can see, the compiler is not happy. The iterator gives us references, and we need the actual own type. Our first instinct might be to do this, a map statement where we dereference each element. This will get rid of the compiler error, but now we have a warning if we activate Clippy. We're trying to use an explicit closure just to copy the elements, when in fact Rust has a specific adapter to handle this use case, which is .copied, which will make an iterator copy its elements. I'm calling it here after the take call because the take also returns an iterator. If I wanted, I could have called it after the iter call, and it would have applied to the whole iterator. Okay, so we've handled this for a copy type. What about a clone type? Let me just go above and paste some code. I've defined a struct, a thing with an ID and a name which implements clone. Down below, we're trying to do the exact same thing, only with a slice of things instead of a slice of bytes. And we have the same error. If I try to use the same map statement, I'm gonna get an error, because the thing doesn't implement copy, so now the dereference will try to move from the input to this variable, and we only have a shared reference. Of course, you cannot move out of a shared reference. To fix this, I can replace the dereference with a clone call, which will fix the compiler error, so this code is now correct, but I'm getting the same kind of error from the linter. We're using an explicit closure just to clone the elements. The adapter for this would be .cloned, which will make the iterator clone its elements. Of course, the same kind of rules apply as in other places. Copy implements clone, but clone doesn't implement copy. So if I try to use the copied adapter here, it will fail. Because the trait bounds are not satisfied, copy is not implemented. Let me just fix this. But if I try to use .cloned here on a copy type, it will work. But I wouldn't recommend it, as it's not very transparent as to what's happening here. So if you can just use copied, just leave it at that right now. So we got the first 4 elements. Let's say we want to do something with the next 4 elements. How would we handle that? Let me just copy this code. Okay, let's rename this second segment. Okay, right now, this code is incorrect because I'm calling .iter twice, and this will create a new iterator for me from the reference, from the slice. And the problem is that the take call, instead of taking the next 4 elements, it will just take the first 4 elements again. So to handle this, I'm gonna save a variable with the iterator. Let's say byte iterator equals input.iter. And let's just replace this byte iterator and byte iterator. And now we have another compiler error. And in this case, this is no longer valid because the take call moves So this will move from the byte iterator to first segment. So this takes ownership. And after this call, byte iterator will no longer be valid. The problem here is that we're not trying to take the first 4 elements without moving. And you may have guessed it, there's another adapter for that, which is byref, which essentially uses a reference for the upcoming calls instead of taking ownership. Oh, and to fix this, I forgot to add mute to the iterator to make this valid. Okay, so this will essentially use the reference instead of taking ownership. And now this reference is valid here, so we can use it to take the next 4 elements that are left in the iterator. Of course, if I want to do this a third time, I would have to call byref here as well, because after this point, byte iterator is no longer valid. Alright then, I hope that's been useful. I'll see you next time, and let me know in the comments with any type of feedback, questions, suggestions. Alright, see ya.